So if I have to introduce SAVEGREEN in one sentence, I would make it this way. So let me read this one. SAVEGREEN will contribute to improving structural and functional ecological connectivity in bottleneck areas by adapting land use and management in the surroundings, involving stakeholders from different fields of experience in Austria, Bulgaria, Czech Republic, Hungary, Romania, Slovakia, and Ukraine. Here in a nutshell, key data of the project. The most important information now is that this is an ongoing project, so I'm not able to show final results yet. However, I can present you with the preliminary results on the present stage. The project comprises certain partners with different backgrounds. We build on existing collaborations with the aim of expanding them as the project progresses. Here you can see the location of the selected pilot regions which stretch from Austria through the Czech Republic, Slovakia, Hungary, Ukraine, and Romania to Bulgaria. In the pilot regions, various sectors are important with which cooperation is sought. First and foremost, it is about agriculture, forestry, water management, and spatial planning. And here is a set of selected target species groups to be monitored in the pilot areas. Of course, there's some overlap. An example, species that will be monitored at all sites, but each study area will focus on a range of species relevant to the specific pilot area. Of particular importance is that the focus is not only animal groups that are commonly monitored, like large carnivores, but that animal groups that receive little attention, such approaches are also considered. So like crayfish, pollinators, and there's one pilot region looking at butterflies. Of particular interest in this project is the relationship between structural and functional connectivity. So here, structural connectivity describes the permeability of the landscape due to the land cover and land use characteristics in that region, while functional connectivity relates to the interactions of animals with the landscape and its structure due to the needs. Starting from the structures located in the landscape areas whose features suggest an impediment to ecological connectivity, so-called bottleneck situations, are to be identified. This is done by using GIS methodology. At these locations, targeted monitoring using field service will check whether and how an impairment exists, taking into account the embedding of these locations in the landscape context in order to investigate the functional connectivity. With this approach, disturbance of functional connectivity will be identified and specific proposals for improvement will be developed together with local stakeholders. So from now on, I will report on the progress in the pilot area of Pöttching on behalf of other pilot areas. So this pilot area is located in the eastern part of Austria and it is part of the Alpine Carpathian Corridor. The following points are essential for modeling structural connectivity in this project. So here it is transparency, transferability, and reproducibility. So this is ensure that the method can be carried out equally for all pilot regions and the results are thus comparable. Furthermore, this methodology should also be set up in such a way that developments can be derived in the future with the help of updated information. Therefore, the goal is to work with a uniform dataset and the same methodology for all the pilot regions. And this makes it clear that the aim is not to achieve the most perfect model result possible for a specific site or a specific area, but to develop a management tool that meets the above mentioned requirements. This diagram illustrates the modeling process. Based on spatially explicit data, a set of rules is used to define core zones, core areas, which serve as a habitat for a specific animal group, and real system maps, which illustrate how difficult it is for a specific animal group to cross the landscape. The majority of the input data required for this consists of freely available sources, above all the Copernicus Land Monitoring Service, as well as the collaborative project OpenStreetMap. Here only the information on over and under passes requires regional or local knowledge. Finally, the linkage pathway tool is freely available tool is used to derive the corridors. For this project, we need area-specific statements about corridors instead of linear representation, and therefore we delineate the grid result using a threshold to delineate these areas. In order to estimate the permeability of certain sections of the corridors, segments are calculated in the first step, and bottleneck situations are calculated in the next step using the pinch point mapper tool. These two maps are then combined to define areas that are likely to affect the functionality of a corridor. Based on these results, the locations for functional monitoring are then determined. Here, for the pilot area patching, these are 16 preliminary sites. These are mainly concentrated around two green bridges in the area, both of which play an essential role for the corridor. Of interest here are the areas that could be restrictive for the functionality of the green bridges. However, localities that are not suitable for monitoring have been omitted. For example, wildlife cameras are not installed in the middle of a field. In addition to the context of the green bridges, a possible corridor further east is being investigated. We are currently in the process of setting up these sites in consultation with the local hunters. This table gives an overview of which methods are used in the monitoring the sites. As you can see, the method depends on two factors, namely the animal group studied at a specific site and the habitat available on the site. For each combination, a certain set of methods is available, which will ensure the comparability of the results in the end. In the pilot area patching, we will focus on large herbivores as target species, like red deer and wild boar. But roe deer will also play an important role. These species will act as umbrella species for other groups like other medium or small-sized mammals. Large carnivores play a subordinate role in Austria, despite their increased occurrence recently. Ultimately, only inadequate statements can be made here. Nevertheless, we are curious whether we will gain new insights here. And really a very important aspect of the project is that on the one hand, a field application based on the free tool QField is to develop, and on the other hand, an existing application with the name of Roadkill is to be extended to enable fieldwork to be carried out on a digital basis. All the collected information of the fieldwork will then be transferred to a database, and this will be finally presented to the public also in a map form. And of course, this will also serve as inputs for analysis carried out in the project. So let me conclude with a list of expected outputs of the whole project. So on the tackling side, a monitoring system with a field application is being developed to help record structural and functional properties of the constructions in order to draw conclusions about which properties work better for corridor permeability and which do not. In the pilot regions, catalogs of measures are being drawn up in a participatory manner. In Austria, together with the ASFINAG, which is the authority for motorways, the Ministry, the Chamber of Agriculture and local authorities, mainly on community level, and landowners in the two pilot areas. We invite representatives of other pilot regions to international workshops, where the catalogue of measures will be the topic. As you can imagine, in times of Corona, this is not an easy task. We like to develop a teaching program for authorities and other relevant stakeholders that will be created to improve the practice of integrated planning. At the political level, we aim to better integrate green infrastructure into funding programs, as well to elaborate joint declarations with the Danube strategy at the Carpathian Convention, which will be presented at important international events. And finally, we want to conclude the project with an international conference in cooperation with the ICOET, the Infrastructure and Nature Network in Europe in 2022. So I say many thanks, and I'm looking forward to your questions.